Hey, g'day, it's your old mate Presso here, back in the shop, and thanks for dropping by. Today's video is about making a cast brass nameplate from this pattern. Now, I started this job some time ago, and the reason I'm doing this is that I built a garden bridge, and one of my regular viewers commented and said, you know what, you've got to have a cast nameplate on a bridge detailing the year it was built in Roman numerals, and it should preferably be named after someone significant. Now, I detailed all of this in a series of videos, and you can check the playlist if you want to go back and look at that. I also showed the manufacturing of this pattern, which was made from laser cut lettering, which was glued down to a plywood back, and the interior surface of that has been treated with an epoxy resin to form a fillet around the edge of each letter. And I said I was going to go ahead and show you the casting process, and as luck would have it, I went and bought a brand new crucible, a graphite crucible, and I found out that it would not fit inside my old gas-fired furnace. So then I had to set about building a new furnace, and once again I started that series of videos on the furnace build. Check out the link. Now, I won't lie to you, when I started this process of making the sand mould, I had two absolute failures, one after the other. And the reason for that was that the sand that I was using, the green sand, was a little bit too moist, but also I was using talcum powder as a parting material. Now, you've probably done what I do, and you checked out lots of videos on YouTube, and you see people using talcum powder as a parting dust. And it sort of works, but if your sand is too wet, you're going to get sticking between the two surfaces. Now, I found out that this is the correct material to use. It's calcium carbonate, and I bought this online at a vet supply place of all things, and they use it as a supplement for horses. And it's just in a little muslin bag, so I can shake that onto the surface of the sand and the pattern. So I'm keen to see how that's going to work out. Now, the raw material I'm going to be using for melting in my furnace is this stuff. Now, just recently we did a reno on the house, and we replaced all of the brass door furniture with chrome plated brass, Art Deco of course, because I like that. And when you buy these brass door handles, they look great, but it's not long before they start to tarnish and corrode, and they feel horrible and they look horrible. So all of this scrap is going to get melted. That's going to become our raw material. Anyway, let's not faff about. Let's get busy with ramming up the sand mould. The first time I did this, the sand wouldn't even go through this sieve, so that should have told me that the sand was a bit too wet, but like a fool I persevered. And this sand is homemade. This is it's called Ballina white sand. I just got it down to the local landscaping supply company, but it's a very fine white sand, and I just added bentonite clay. The bentonite I bought from a local rural supplier, and it was sold as a product for sealing clay dams. And when I got it, it was a little bit lumpy, so I put it through an old kitchen blender and just kept working it until it came out very, very fine. I couldn't even tell you what the ratio was. I just kept adding the bentonite until it looked and felt right. And I'd dearly love to have some Petrobond, but it's almost difficult, or it's almost impossible to get in small quantities at least. So we're stuck with this, and I'm not even sure whether sifting it like that is necessary. You can see there that sand is holding together pretty good, and it's not sticking to my hands like it did the first time. So here's my Buffy the Vampire Slayer steak. Seems to work for me. Alright, well there is the bottom half done. This is where it all went wrong last time when I used talcum powder here. So I'm keen to see how this works out. Now this little piece here is to make a standoff. Because of the way this has to be attached to the bridge, it needs to have that little button on either one side or the other depending on which of these plaques you're doing. And that's to do with the way the cross bracing works on the bridge. This will be swapped from there to there when I do the other one. Now I was watching Old Foundryman, a channel that I found on YouTube, and when he makes a riser he uses a shape like that, and it just fits into one of the holes. So I'm going to put that right in the middle, and I think the notion is that you want a good bulk of material in the riser to replace what gets used up in contraction of the metal. And it's easier to saw off because of the tapered shape on the end there. At least I think that's what it's designed to do. Now this is the bit that I never used to do. I used to just pour the metal straight into the sprue. And I was watching Old Foundryman doing this, and he always makes a thing called a pouring basin. Probably does a lot better than I do. But this is where you're going to pour the hot metal into this depression here. And the idea is that it overflows into the sprue and slows down the velocity of the metal as it enters the sand cavity. I think that's how it's meant to work. Of course, he always makes it look so easy. Never quite that way for me. Now you can see, even there, that's stuck a bit, but it's way better than what it was. Okay, not sure if that's right or not. Okay, beautiful. Now, this is the other thing that I saw old foundrymen do. They just put a little bit of that parting dust into that area there. And that little bit of magic is going to make it work, I reckon. Okay, so this one's done. I've got to actually make two of these, but I'm going to do one, see how it goes, and then if it's successful, we'll do the other one. If it's a complete screw up, I'll make it out of aluminium. Okay, all ready to go and light this furnace up. So before I do that, I just want to run through some of the gear that you're going to need if you're doing this. And I'm guessing that if you're watching this now, you have an interest in building your own home foundry, or you've already done a bit of it, but just let me run you through what I use in my setup. So this is my brand new furnace that I just built. It's got the graphite crucible already inside. I'm going to heat that up without putting any scrap brass in it. I'm going to wait until it gets to a sort of a dull red heat, then I'll introduce as much of that brass as I can get in there. My fuel is propane or LPG. I don't use a regulator, I just run it straight from the valve on the top of the cylinder. I can regulate the amount of gas by listening to the flame, and generally if you hear it making a continuous roaring sound, it's good. If you hear it starting to flutter, it means that your pressure in your cylinder is dropping and you need to introduce some more gas. Alright, I've got my stock here. This is all my scrap brass waiting to go into the hot furnace. I've got my safety gear, so I wear some heavy leather gloves, wear a face shield just to protect your face from the heat. This is more about being able to look down into the furnace without singeing your eyebrows off, basically. I'm wearing leather boots and overalls. I also have a pan here which I use to ladle the dross into, just so I don't throw it on the concrete floor. I've got a muffin pan here which is just for any leftover stock when I'm finished pouring my melt. I've got my sand flask sitting there waiting for the hot metal to go in. Now, other tools that I'm using, I've got my lifting tongs here ready to go. I've got a pair of pliers. These are just ordinary pliers, and I welded some extension handles onto them because I don't have any blacksmith's tongs. This is so I can just lift any of that scrap brass into the crucible without chucking it in. The last thing I want to do is to splash hot metal everywhere. I've also got a hook here. I just use this for sort of moving things around inside the hot crucible. Things that sort of get hung up and don't want to melt into the liquid metal in the bottom. I've got just an ordinary old kitchen spoon here for lifting out the dross. Seems to work for me. I've got a ring shank weighting for the hot crucible, and that'll allow me to lift and pour the hot metal into the mould. Now, one more thing. Somebody had asked me about this burner that they'd seen me do in another video, or using in another video. This is one that I built myself, and I'm just going to give you a closer look at it. Now, it's a piece of stainless steel tube. It's 32 millimeters diameter, OD. It's got a 2mm wall thickness, and it's around about 300 millimeters long to this section anyway. So that's just the steel tube. Now you could use ordinary mild steel or galvanized steel water pipe or whatever you like. This is good because it doesn't corrode. You know, if you use steel, mild steel, the heat's going to burn off whatever coating you've got on there, and it's going to start to corrode on that end. Now, I press fitted a steel, what would you call that? That's a jet holder into the end of that tube. Now you could weld it, you could thread it and just screw it on in there if you wish to. And this section here was turned on the lathe and reduced down to give me a slightly thinner section, because what I did next was I started to file away this air slot. Now the idea is that you start with a fairly small slot, you run the burner and see what the flame looks like, and you gradually increase the amount of opening to allow just the right fuel and air mixture. Now this end of the fitting is closed off, but it's threaded for a pipe thread, and the actual jet is a separate brass nipple that's threaded into the center of this section here. Now I know you can't see it, let me get some light on that. Is that working or not? Yep, you might just be able to see that brass jet. There you go, that's better. So that's just a piece of hex brass. It doesn't matter what the thread is, just whatever you've got on hand. Now the jet is a number 60 drill bit. Now once again, I think I just started off small and I gradually increased that, but number 60 seemed to work quite well. Now the idea is that when you light this up, you should get a steady blue flame from this end. If you get any tinge of yellow, you're not getting enough air mixed in with the gas. If it sort of looks like it's fluttery and it's about to go out any minute, you've probably got too much air. Now if you've got too much air, you could make actually a little sliding collar around here to close off some of that air vent. Now if you remember back to your high school science, when you used Bunsen burners, you'll remember how that worked. Now I think I just got lucky and I had just the right amount of air opening there. Well, I'll get a rule and I'll tell you what that dimension is. Okay, so we've got two slots and they're around about 16 millimeters wide that way, and it's around about 19 millimeters across from side to side. So 16 wide, 19 across, and there are two of those on one on either side. And for all of the rest of the dimensions on my burner, that seems to work really well. So the flame that I get is stable, it's got just the right mixture of air and fuel, it's easy to light, and it goes out easily when you turn the gas off. So that's it. You know, materials, it's whatever you got on hand, and I think that, you know, if you look online, you'll see lots of burners that are designed around pipe fittings, and you've got to get exactly this pipe fitting and exactly this jet size and so on. I think, you know, the design of these things is fairly flexible. At least for me, it sort of worked first time. Okay, but that's my burner. Alright, well that was seriously scary. If you're not used to casting brass, it's way hotter than aluminium. Just trying to scrape the dross off the top of the crucible while it was in the furnace, it was actually burning my gloves, and I could feel the heat coming through, so I'd take it out, rest on a brick while I finished off removing that dross. And it started to come up through the riser, not all the way, but it looked like it completely filled the pouring basin, so I decided not to go any further. But, well, I think that went okay. I measured the gas cylinder before I started, measured the weight, and I'll measure it again now, just so we can work out how many kilos of gas that I've used. Alright, let's see what we got. And I did measure the gas, and we've used 1.7 kilos out of roughly 8.5 kilo bottle. Ah, disaster. Look at that. What happened there? Ah, damn. Alright, well, that's fail number one. I guess my brass wasn't hot enough. Maybe my gates need to be bigger. Okay, well I've got one more flask made up. I'll have one more go. It's the best I can do. That's really disappointing. I thought that it worked perfectly. Well, for what it's worth, this bit turned out beautifully. There are a couple of defects, like the letter N there, but I can live with that. I'm still at a loss to explain what happened here. I'm guessing that the metal just solidified before it run all the way through. So I'm going to try again, but I suspect that I'm going to get the same result because I gated it exactly the same way. And I think that probably what I need is hotter metal or better gating, like bigger gates, and maybe the riser should have been put somewhere down the end, down here, so that this cavity had to completely fill before the riser filled. But I must say, this is a bit of one of those black arts, you know, that you can learn by trial and error. And I'm sure there's all the gurus out there watching me and saying, well, you idiot, you ignored the basic rule of gating, whatever that is, and this is the result. Anyway, let's give it one more go. Well, I didn't capture that on camera because my battery's getting really low, but I did a second melt, and this time I took it up to a much higher temperature. I started pouring in the pouring basin, and then when I'd partially filled the mould, I dumped the rest down the riser hole. Now my figuring was that I was going to get a second failure anyway, so I had nothing to lose. And I decided that if I had the area directly below the riser partially full of metal and then just pour the rest in quickly, I was less likely to do any damage. But we'll take this one out and see what we got. But I suspect it's going to be the same. So what? Oh, that's better. Don't know what made the difference, but maybe it was just getting the metal to a higher temperature. And my unconventional method for getting it into the mould. I sort of thought that it would work because I used up a lot more metal in the crucible. But okay, let me get this cleaned up and we'll check it out. All I've done there is I've belt grinded that to remove the surface of the lettering, and it's come out pretty good. Cleaned up the edges, they had a little bit of flashing on them. The back has come out pretty good. This is where one of the fixing bolts will go, and this is just the offset that I need for the diagonal bracing on the bridge. The other brass plate will have that feature at the other end. This is where the riser was. That's going to be milled off or ground off in some way. The surface texture on the background here is a little bit rough, and that's probably a consequence of the green sand that I'm using, which is not the best quality. What I'm going to do next is I'll do a proper clean up on this, and then this will be powder coated all over, and then I'll grind off the lettering again to give you the contrast between the background and the lettering. But overall, I'm pretty happy with that. For a second attempt casting brass, and I think this is a fairly challenging casting anyway because it's so long and thin, and as we saw with the first example, the metal tends to cool very quickly, and I think that having the higher temperature might have made the difference. Well, this is the second one of these I've done this morning. I'm having trouble with the centerpiece of these lettering popping out, and I've lost the center of the A, center of the R, center of the R there. And like an idiot, I forgot to put the little riser piece on, this odd piece. But I'm going to cut my losses and do this one. If it turns out I can grind away the center of those letters. When it's powder coated, you won't know. So I'm going to go ahead and see if we can get the metal to flow in this one. The difference this time is that I put much deeper runners, and I put 4 gates in instead of 3. And from what I read yesterday, I think this is the answer, but we shall see. Alright, please be good. Yes! Oh, it's about time. Oh, that's a relief. That's like 4 attempts, 2 fails. And even this one, it's got a few little defects, like the centers of these letters with the closed loops. So I'm just going to do some remedial work on those. But from what I understand, the gating when you're doing these long, thin castings is really important, and there's lots of scientific data and formulas, and Bernoulli's principle comes into it, fluid flow, that sort of thing. So I'm really just experimenting here, but tell you what, I don't want to do this again. This is definitely a one-off, and from now on I'm sticking to aluminium and sticking to big chunky castings. We've got 2 good ones, so I'm going to get this one cleaned up, we're going to powder coat it, and I'll show you what they look like when they're done. Well, there it is, that's finished and mounted on the bridge. The colour is called sterling charcoal. It's a semi-translucent powder coat, and a good thing is that you can see the texture of the sand cast surface through the powder coat. On the other side you can see the other one there, and I'll eventually paint the back of these orange, the same as the cross bracing. And this one is the second one I did, the one I had the most grief with. And you can see the centre of the A, I think there was some detail around the S here, centre of the R. I got a Dremel and a rotary burr and just deepened that area. And the only other defect I got was here, just on the bottom of that A. But I think that adds to the overall effect, the cast brass effect. At least that's the excuse that I'm going to use. So you can see here the method I've used to mount these on the cross bracing. There's just a brass stud threaded into the nameplate itself. I've got a hex brass nut keeping everything together, and I can remove these plates now if necessary. So I'm not sure how this powder coat's going to stand up to the environment, but you know, I think it should be alright for a while anyway. So would I do this again? Would I do cast brass? Well, certainly not for a project this complicated. I really should have started something that was easier. Apparently these thin, long castings are quite difficult to do, but I think it was worth it in the long run. So that's it for now. In a forthcoming video, I'm not sure if it's going to be the next one or not, we're going to have the grand opening of the bridge, and there'll be a special guest invited along to do the first walk across the bridge. We're going to have fun for all the family, so join me then, and it's going to be fantastic. Okay, and that's it for now, and thanks for watching.